are going to continue our talk about gravity. Gravity, gravity, gravity. And gravity is more than just the force between you and Earth. You know, gravity is what keeps us here on Earth, right? Gravity is what gravity is what's keeping everything in this room on the floor. If we didn't have any gravity, what would happen to these napkins right here? They just start floating up, right? And even me, I'd start floating up, right? Okay, so but gravity is more than just the force between you and Earth. It's also the force between any two objects in the room. Now I want you to try a little experiment here. I don't want you to get all the way up, but I want you to just raise up just a little bit and tell me what your body wants to do.
Wants to just sit
No, lift. I want you to lift your bottom off your chair a little bit. What does your body want to do?
It wants to go back down.
It wants to sit back down, doesn't it? It does, doesn't it? If you get like halfway up, what's your body going to want to do? Woo, it's wanting to sit back down, right? Okay, well, let me tell you that part of that is because there's gravity, which is force, between any two objects in the universe. Okay, you got what I'm saying here?
Yep.
Okay, so right now there's an attractive force between you and they use the word desk, but I'm going to say chair and table, right? So the force is so small though, because you and your desk or your chair are very tiny compared to the whole universe, that is. Right? The whole universe. Woo! Okay? Okay, so let's look right here. Gravity is the force that holds each galaxy together. What holds the galaxies together? Gravity. Gravity holds each galaxy together. It holds all the galaxies together, actually. Everything in a galaxy has a gravitational pull on the other objects around it. So, okay, so we're in a galaxy, right? What galaxy are we in?
Milky Way galaxy.
Milky Way galaxy. Yes, we are. And we have a sun, right?
That's a star.
Our star is the sun. Our star is the sun. We call it the sun. And does it have a gravitational pull on Earth?
Yes.
Yes, it does. It does. And how about the moon and the Earth? Do they have a gravitational pull on each other?
Yes.
Yes, they do. Okay? So, listen. So, everything in a galaxy has gravitational pull on the other objects around it. So, how large that force is depends on two things. Remember, this is a question about it shortly. The size of the objects and the distance between those objects. So which would be, well, never mind. We're just going to go on here. You'll see it here in a second. Oh, there it is right there. Okay, here we go. You ready? All right. Which of the following would you have most gravity? Which of the following would have the most gravity between them? Would it be two ping pong balls at 1 meter apart? That's about 3 feet. Two ping pong balls at 2 meters apart. Two bowling balls 1 meter apart. Two bowling balls 2 meters apart. Well, here, let's do this. I'm going to help you out here a little bit. You can't choose B or D because they're 2 meters apart, and we already said size and distance, right? So we can just by logic we can say, well, 2 meters is farther apart than 1 meter, so let's just get rid of the 2 meter ones, and we got 1 meter apart, right? And those 1 meter apart. So it's either A or C. So now you can think to yourself, oh, which one of those is the largest object? And choose that answer. That's how you would follow the logic of the answer. So what's our answer here, A or C? Mark your answer. Can't choose B or D because they're 2 meters apart. Okay, everybody got an answer? Okay, I'm going to move on here. Okay, there is gravity between you and the moon. Is that true? What did we just say here? What did we just say here? Look here.
Yes.
Everything in a galaxy, everything. Are you a part of everything?
Mm-hmm.
Yes, you are. Everything in a galaxy has a gravitational pull on the other objects around it. So now let's go answer this question here. There is gravity between you and the moon. Is that a true statement or a false statement?
True.
Mark your answer. Don't blurt out an answer. It's okay. Just don't blurt out answers. Okay, so let's look right here. There is gravity between the Milky Way galaxy and other galaxies. Is that a true statement or a false statement? True statement or a false statement?
What's the question again?
There is a gravity between the Milky Way galaxy and other galaxies. Is there gravity between the Milky Way galaxy and the other galaxies? Let's go back to our original idea here. Everything in a galaxy has gravitational pull on the other objects around it. Okay, so here we go. Mr. Hughes needs water. Everybody got an answer? Is this easy so far? Okay. Okay. I'm going to move on here. Okay, let's look at the center of a galaxy. The center of a galaxy. Look here, due to gravity, galaxies are always revolving. That means they're moving around. Look here, we're in the universe and these galaxies are just doing this right here. How many galaxies do we have?
Endless?
Huh?
Endless?
Could be endless. Okay, so due to gravity, galaxies are always revolving. But what are they spinning around? Well, scientists believe that at the center of each galaxy is something called a black hole. Look at this picture right here. What's this right here?
Black hole?
Oh my God, what's it doing?
Sucks it in.
Here's stuff coming toward it, and what happens when that stuff gets there?
It sucks it in.
It sucks it in. That's exactly right.
Well, that's why some stuff
Okay.
is going away because of the black hole. The more
That-
it gets, the bigger it gets.
Okay, now we're going to talk more about black holes a little bit later, okay? Okay, so right here, I am going to stop this video. Oh, yes I am. I am going to stop this video right here. Because we got two questions, or actually there's 3 or 4, I think. Like 4 questions we got to answer. On second thought, I'm not going to stop this video. Hang on.
Can I go to the restroom?
Not right now, you wanna watch this video first. Unless it's an emergency. Okay, put that front light there, would you?
This one?
Yes.
Okay.
Okay, look right here. What do you see a picture of right here, do you think?
Universe.
The universe? Oh, no, it's not the universe.
Milky Way. Galaxy?
A galaxy. Is this the Milky Way galaxy?
No.
Well, who knows?
It
Okay,
could.
but it is a galaxy, right? Based on what we know about galaxies so far in the pictures we've seen. This is a galaxy. Now, I want you to pay attention to the number M31. M31, because that's the name of whatever this thing is here. It's called M31. And then there's another M that's a little bit, that's down in here. I think it's down in there, maybe. And guess what that is? Another what? Galaxy far, far away. Now that's called M something. And the reason they give them names like that is, what galaxy do we live in? Milky Way?
Milky Way galaxy.
I don't know. It could be called Milky Way 31. I don't know. Anyway, just pay attention to the number M31 because we're going to be asking about 3 or 4 questions about this video that you're watching here. And it's real simple, okay? I will stop the video and we'll talk about it a little bit about it.
Hi.
This is a tour of M31.
So check my Chromebook real quick. It's like down.
Huh?
My Chromebook's better than that. I don't have trusted.
There's a, right there.
Hi, I'm Stefan Imler, a research scientist working with NASA's Swift satellite at Goddard Space Flight Center in Greenbelt, Maryland. This is M31, the nearest large spiral galaxy to our own. It's about 2.5 million light years away and more than 220,000 light years across. This is how we're used to seeing it in the visible light captured by ground-based telescopes. But visible light never tells the whole story.
Too loud. Please turn it down a little.
Is it making you nervous?
It's loud.
Hey, listen, you guys watch the video. This isn't sleep class. It's not gonna ever be sleep class.
I'll sleep when it's loud.
Well, I'll send you down here to Miss Campbell, let her take care of that. I promise you'll be going to CEO. They got it open up now, they got plenty of seats.
Can you tone it down?
You better hush. You're making me nervous. Hush. Hush, hush, hush. Just for you, I'm gonna shut it down a little bit. Now hush. Is that better?
Yes.
Hi, I'm Stefan Imler, a research scientist working with NASA's Swift satellite at Goddard Space Flight Center in Greenbelt, Maryland. This is M31, the nearest large spiral galaxy to our own. It's about 2.5 million light years away and more.
Did you hear what he said? This is a galaxy nearest to our own. It's about 2.5, what did he say? I think he's gonna tell us here. It's about 2.5 million light years away, I think is what he said. So how long will it take to get there? You know how long a light year is? How long is a light year?
I don't know.
Well, it's it's a long way.
I guess I'm decade.
More than 220,000 light years across.
So this galaxy is 220 light years across. That means you'd have to be traveling at the speed of light for 220, what did we say? 220 years? Is that what he said? Let's look and see here.
220,000 light years across.
220,000. So you would have to be traveling at the speed of light. You'd have to be traveling at the speed of light, which nobody knows how to, at least we don't know how to travel with the speed of light. You'd have to be traveling with the speed of light 220,000 years to get to this, if you leave Earth, you'd have to travel at 220,000 miles at the speed of light. 220,000 years at the speed of light. Are we gonna make it there? No, not with the technology that we got now.
This is how we're used to seeing it in the visible light captured by ground-based telescopes. But visible.
So how'd they get that picture? A telescope, right? A telescope on the ground. Not a little one, but one of those big, gigantic ones with the observatories. That'd be the kind they're talking about.
Light never tells the whole story. So between May and July 2008, Swift's ultraviolet optical telescope captured 330 images of M31 and 3 ultraviolet wavelengths.
And what kind of light did they use to capture that? UV. You guys know what UV light is? Ultraviolet light. Now remember that. There's going to be a question about it. Ultraviolet light.
Total exposure time, 24 hours. We combine these images into this mosaic. It's the most detailed view of M31 in the ultraviolet to date. The first thing you notice is the striking difference between...
And so you see what he just said? He said they are observing this in ultraviolet light. Okay, and then when you get ultraviolet light, ultraviolet light, the cooler colors like red, the hotter colors like red, you'll listen to what he says. Then there's blue colors.
In the galaxy's central bulge and its spiral arms. The bulge is smoother and redder because it's full of older and cooler stars. Very few new stars.
So why is it red? Why is it red? Cooler and older stars, right? These are older stars. Okay, so here we go.
From here, because most of the materials needed to make them have been depleted. In contrast,
So what he's saying is, because these are old stars, there's not a whole lot going on in that part of the galaxy, right? There's not a whole lot of material there to make life. But let's see what about the other part of it.
M31's spiral arms sparkle with dense clusters of hot young blue stars.
Okay, so look here, blue, these are young blue stars. What do you think's gonna happen there? Woohoo! What's gonna happen?
Oh no.
You could get some life going on here because they have a whole lot of material to work with, and they're gonna be exploding and throwing gas and dust out in the air and all those elements. You remember our Big Bang could be new planets, yes, starting, and then what happens with new planets? What's the potential for a new planet? What could you get from a new planet maybe?
Something
Especially if
very.
it's right in that Goldilocks zone. You guys heard of the Goldilocks?
Just right.
But everything would be just right, yeah, for life. So, and that, now remember, this is 220,000 light years away though. Wow, if we can figure out a way to get there real quick.
As in our own galaxy, the disk and spiral arms contain most of the gas and dust needed to produce new generations of stars. M31's clusters are especially plentiful in the
Listen, he just compared this part of this galaxy with the Milky Way galaxy. Our galaxy is relatively young. This is a relatively old galaxy, but part of it is young, right? Part of it's young, part of it's old. Our galaxy is a young galaxy.
a giant ring around the galaxy. It's about 150,000 light years across. This ring of fire exists because of tidal interactions with small satellite galaxies. Speaking of which, this is M32, one of many dwarf galaxies orbiting M31. These galaxies are usually not very bright in the ultraviolet because they lack young stars. But M32's core is so bright in the UV because it likely contains many blue and old stars. The Swift mosaic reveals some 20,000 UV sources. It's important to study star formation processes in nearby galaxies so we can understand what we're seeing in distant galaxies. This rich portrait in 3 different ultraviolet wavelengths allows us to study how M31 stars live and die with much greater detail than previously possible.
You ready for the question? Oh, yes, you are. Oh, yes, you are. Here we go. Here's your first question right here. Look here, you remember those red, the stars at the center of the M31, that galaxy, the ones with the red parts, are they larger and brighter or are they older and cooler? Mark your answer, A or C. Isaiah, what's up here, dude? I need you to answer these questions here now. Unless you're sick. If you're sick, you need to go up here to the office and see the nurse. Otherwise, I need you to participate here. Isaiah, come on here. Let's take care of business here. Take your hoodie off your head here. Come on. Stop pouting. Here we go. Chop, chop. Gotta take care of business here. Okay, so look here. The stars at the center of M31, are they larger and brighter, or are they older and cooler than the stars close to the outside? You know, the ones from the outside that were blue, and I'm not going to say anything else. Okay, everybody got an answer? It's either A or C. Okay, look right here. Now, just like in our galaxy, it's what he said, just like in our galaxy, the spiral arms of that M31 contain the gas and dust. That's where the blue part was. They contain gas and dust needed to make a new generation of what? Stars or comets? Stars or comets? Mark your answer. Did he say comets? Did you hear him say comets, or did you hear him say stars? Mark your answer, A or D. Everybody got an answer? Yes, Mr. Hughes. Okay, I'll give you about 5 more seconds and I'm moving on. Okay, let's look right here. So the Swift telescope, that's the one on the ground, big, gigantic, like an observatory. The Swift telescope allows distant objects to be studied using both something and visible light. Is it radiant light or ultraviolet light? A or C, mark your answer. The Swift telescope allows distant objects. Now remember, this galaxy was 220,000 light years away, and it's our nearest galaxy. So you would have to travel 220,000 years at the speed of light to visit that galaxy with our current technology. Well, we can't travel at the speed of light. That's 186,000 miles per second. The speed of light. Okay, everybody got that answer?
No.
Okay. You have to think back to the video to get these answers. They're not on the slides. Okay, everybody got it? Everybody ready? Okay, let's talk about light years. Let's talk about light years. You know what we're gonna do? We're gonna end this right here. We will talk about light years Monday. We're actually
What about Friday?
tomorrow we're gonna be in Study Island.
What about taking a mass break today?
What?
A mass break?
I don't know.
Can we do it?
I don't know. You wanna take a mass break today?
Yes.
It won't be now.
It
We might
will-
take a mass break in about 10 minutes.
Okay.
Brandon.